This is going to be a follow-up to the Pullback Truck Acceleration Quick Lab. The goal for this lab was to find a relationship between acceleration and mass. That's always important to keep that in mind when you're doing the lab. What are we trying to figure out? A relationship between acceleration and mass. When one changes, how does the other one change? That's what we're trying to do. So we used the pullback trucks and the motion detectors, and we measured how much acceleration would be versus how much mass there was, total mass, the truck plus any added mass. And then you're supposed to plot some points in Desmos and fit a curve. So I've plotted some points in Desmos over here. So what I have in my x column is the mass, and then here's my acceleration. And when you plot points like this, sometimes in Desmos you have to work with it a little bit because there's no points. The problem is that my vertical axis is different than my horizontal axis in terms of the numbers. So a couple things I could do. I could go over here into graph settings, and I could change my y-axis to say like 0 to 3 or 400. That would be fine. Another thing that's just as quick and easy is if I just change all these and put a decimal in, 1.1, 1.4, 1.6, 2.0, 2.2, 2.6. You might be like, well, that's changing your data. It's not really. I'm just changing the order of magnitude of my data. So it doesn't change the proportion of everything. If all I'm really looking for is a relationship. So I get this interesting set of data points over here. And some of you maybe were thinking of putting something like y equals mx inside of there, adding a slider for m, and saying, oh, I got to add a plus b, I suppose. Plus b, put in a slider for b, and I can get something that fits pretty well. You're never going to fit all your data points. A couple issues here is that I can't really cross the axis up here. That would mean that zero mass had some finite amount of acceleration. Where it should be that if I had zero mass, I should get an infinite acceleration if I still had some sort of force inside there. Also, I can't cross the axis here because if I get more and more mass, I shouldn't get a negative acceleration. So this is not going to work out. I need some function that's going to stay in this first quadrant. Also, people were looking at exponentials. Exponentials can't be at either because it's going to cross this axis over here, or log functions cross this axis. And it turns out to be actually just the most basic function, y equals a over x. A is some sort of slider, so it's just an inverse function. If I get my slider right, you can see I can actually get my data points pretty well. Now I picked my data points to be really close but not perfect, so your data points might not work out to be this perfect. But here it is. Y on my y-axis, which is acceleration, is inversely proportional to mass, which is on my x-axis over here. So if I look over here and show you, this is what the end result is. Acceleration is inversely proportional to mass. If I double my mass, I have half the acceleration. If I triple my mass, I have 1/3 the acceleration. And we can write it like this. This little squiggly thing, by the way, means proportional to. So acceleration is proportional to 1 over mass. That's the conclusion of the pullback truck lab.